as we said in the first part of this lesson, that data has a story to tell, and our job in this course is to figure out what the story is and tell it to others. Making graphs of the data helps us do both of those things. So sometimes if you're trying to figure out what sort of information is contained in the data, making a graph can help you to figure out what is going on, to help you see trends, help you see patterns. Other times you know what the data shows and you want to tell somebody else what that data is. Making a graph, showing it to them, and presenting the key points in that graph is a good way of doing this. So there's this little comic here which kind of illustrates this. I think we should give it another shot. Says the guy here, we should break up and I can prove it. Counters his girlfriend. She shows him a graph of their relationship, which seems to be in a downward trend. He says, huh? And yeah, he says, maybe you're right. She says, I know data would convince you. And he says, no, I just think I can do better than someone who doesn't label her axes. So a bit of a graph making burn there. So yeah, always remember to label your axes. In particular, what this lesson is going to focus on is the difference between a bar graph and a histogram. Now, if you go through the learning guide, it'll take you through how to do other types of graphs. You've done a lot of graphing before in previous math courses and in other courses that you've taken. Histogram might be the one type of graph that is kind of new to you, so we're going to focus on how you make a histogram and how a histogram is different from a bar graph, which you've probably done before. So a bar graph, as I talked about in the last lesson, involves two variables. One is usually categorical, okay, and the other is quantitative. So in this one, our categorical variable is the team name, which we're plotting across the bottom, and our numerical or quantitative variable is the number of points. So we've made a graph of teams and the number of points that they have. And what does this graph shows? Well, basically it shows the number of points each team have. Now, when you look at this, there are gaps in between the bars on our bar graph here. Why are there gaps in between the bars? Because these things that we're plotting along the x-axis are separate categories. The blades is one team, ice hogs are a different team, okay? And those teams are, well, these are separate sort of categories in our categorical or our quantitative variable. So it's appropriate that there's a separation between these bars. Also keep in mind that we could order this in any order that we wanted along the x-axis. We could have put the slap shots way up here at the beginning, the blades, then the ice hogs, and then, you know, switch the nice guys and the leaves around. And the data would, the graph would still show you the same thing. It would still show you a list of team names and the number of points that they have. Okay. So those are features of a bar graph. And there are also ways that a histogram is different. So what is a histogram? Well, first off, rather than showing two variable analysis, histogram is one variable analysis. So it only operates on one variable in your data set. And what it shows is the distribution of the data over its range. Okay, so what do we mean by range? Range is just the difference between the highest and the lowest value. So you take the highest value, subtract the lowest value, and that gives you the range of the data for that one particular variable. What we mean by the distribution is we want to know where do the rest of the data points in that variable fall over that range. Are they all clustered at the low end of the range? Are they all in the middle of that range? Are they all at the top of the range? Are they spread evenly throughout? What is going on? How are they distributed over that range? So we find the distribution for a discrete or a continuous variable by dividing that range into intervals. And then we count how many data points or the number of values from that variable fall into each one of these intervals. The size that we set for each of these intervals is sometimes called the bin width, sometimes called the bucket size, sometimes it's called the interval width or something like that. Then we organize all of this in a frequency table, which basically tabulates the intervals and the number of things that are in each interval, and then we make a graph from that frequency table called a histogram, and that histogram illustrates that distribution. So let's take a look at an example here. Okay, a toy tricycle comes with this label: easy to assemble. An adult can complete this assembly in 20 minutes or less. And so we do an experiment here. 36 adults were asked to complete the assembly of a tricycle. They recorded their times. Here are the results. So we got a long list of times in minutes here of how long it took these 36 people to assemble the tricycle. The question we want to ask about this data is, what is the distribution of assembly times? Are they all pretty much close to this 20 minutes? Are they all less than this 20 minutes? Are all of them more than this 20 minutes? Or how are they spread around amongst the range? Because by doing this, we can figure out whether this claim here, that you can assemble it in 20 minutes or less, is actually valid. Now, how do we know that this is one variable data? Well, just look at it. There's just one list of numbers there. These are all times. So we can't make a bar graph out of this because we can't have the time. We don't have another variable to associate each of these times with. So we just have this list of times here, and we're going to look for the distribution. So this is clearly one variable. So here's how we make a histogram. We take our data, and first thing we do is we figure out the range. So our lowest value is this 8 here. Our highest value is this 32 here. So 32 minus 8 is 24. Okay. Now, if the data starts at 8 and it goes up to 32, we want to set up some intervals for those different time values that are going to cover that entire range. So if my lowest value is 8, I might have my first interval start at 5. Okay. It's useful to use like round numbers that start with like 5 or 10 or something like that, because it just makes the frequency table a little bit easier to understand, and it makes the histogram a little easier to understand. It's just easy for people to interpret. So if I'm going to start the first one at 5, a good width for this interval, for this bin, might be another nice round number like 5. So the first one might go 5 to 10, and then 10 to 20, then 20 to 30, 30 to 40. Oh, unfortunately, I've changed the size of my bins there. I haven't done that correctly. The bins all have to be the same size. So if the first one goes from 5 to 10, the second one has to go from 10 to 15, and then 15 to 20, and then 20 to 25, and then 25 to 30, and then 30 up to 35. So I've got 2, 4, 6 bins. Each bin is 5 wide, which gives me a grand total of 30 for my range, okay, which is bigger than the 24, the range of 24 that I need to capture. So I'm okay here. Now, one problem that I'm going to have is, like, what I'm going to do here is I'm just going to go through this list, and I'm going to, for each number here, I'm just going to put a check in the appropriate range or the appropriate interval for each number. So 16 is obviously in this interval right here. And then 10, well, we have a problem when we get to 10. Is 10 in the first interval, or is it down in the second interval? Okay. So to make this a little bit more clear, I'm going to say that my first interval goes from 5 up to any number less than 10. And then 10 will be in the second interval up to anything less than 15. Okay, so this would let me be able to do an interval if some of my numbers were decimals up here. So if I had a number like 9.9, it would definitely go in this range, this interval where it's from 5 to less than 10, because it's less than 10. So my number of 10 definitely goes in the second one here. Okay, and then I'm going to cross it off. And my 20 definitely goes in this one down here. And 22 goes in that same interval. Okay, so on and so on and so on. So when I go through all of this, what I'll end up with is a series of tallies. I think these are the results that I'm going to get. Um, so I'd end up with something like this. And by the time I'd gotten to there, I would have crossed off all of these numbers. So the frequency is just the number of things that are in that tally. So I've got 1, I've got 5, I've got 10, I've got 13, I've got 5, and then I've got 2. And I should double check that those things do in fact add up to the number of data points that I expect. 6, 16, 26, 29, 31, 36, okay, which is the number that I expected. Okay, so what do I do with this? Well, now I'm going to make a graph, and it's going to look like a bar graph, and on the x-axis I'm going to have these intervals, and on the y-axis I'm going to have these frequency values. So I'm going to have basically a bar graph of how many numbers are in each one of these intervals. Now it's going to look something like this. So across the x-axis I've got time to assemble. I've got my interval here that starts from 5 and goes to 10. Okay, I've got another interval that goes from 10 to 15, and so on and so on. And on the y-axis here, frequency, so I've got 1 here, I've got 5 here, and so on and so on. Notice that on our histogram here, our bars are right up close to each other. There's no space in between them. Okay, and that makes sense because this interval right here goes from 5 to 10, and then the next interval starts right at 10 and goes right up to 15. So there's no gap in between those two intervals. Okay, they're right there touching each other, and the histogram is designed to reflect that. Now, if when you are making your histogram, if you've made sort of a bar, if on yours you do have some space in between them, that's okay as long as you've made the histogram correctly and the frequency table correctly. Okay, so what does this histogram tell us about the times? Well, the typical time that they had given us was about 20 minutes right here in the middle. So we've got a lot of people, okay, who were able to assemble it in close to 20 minutes. Like most of these people are between 15 and 25, but there's a few who are able to do it a lot faster, and a few over here who it took a lot longer. So what can we say about this claim here? That an adult can complete this assembly in 20 minutes or less? We could say something like most completed in close to 20 minutes. But some took longer. And we could also say some took much less time. Much less time. Okay. So, histogram. X-axis are values or ranges. Y-axis is number of times that the value or value occurs in that range, or it's just another name for frequency. So we've got a bar graph here, which is qualitative along the x-axis, and number of points or some other quantitative variable on the y-axis. And we have a histogram over here, where it's intervals along the x-axis, okay, and frequencies along the y-axis. Now we can take this data here that we have in this bar graph and we can turn it into a histogram. Okay, we can take all of the possible values for the number of points, put them on the x-axis here. So 5, 10, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, so on and so on and so on. Okay, and then we could count how many times we have a team that has that number of points. So it's like there's one team here that has 5 points. So at 5 points, we have a value of 1. There are 2 teams here that have, looks like 15 points, 15 and 15. So where we've got points 15, we have 2 right here. Same thing for 22 points. There are 2 teams with 22 points. So when we get over here to 22 points, we have a bar that is too high. And then finally that last one is 29. So over here at 29, there's one team again. So we can make a histogram out of this data, but in doing so we have to get rid of these team names here. So we don't know which team name corresponds to that particular number of points because we've gotten rid of that second variable. Okay.